Good day everyone, welcome to my maths video. Today I want to discuss a topic called correlation coefficient and the transformation of data. What has transformation of data affect the correlation? So to start off, let's take a look at this PowerPoint that I've created. Okay. Now, sometimes transformation of data is also considered or called coding of data. How do we code the data? We choose the suitable values of constant A, B, and C, and we can transform the data X into A plus Bx over C. However, there are many words to describe transformation of coding. Some are used very loosely. Alright? So things like scaling, normalization are also used. But usually the word scaling is used to mean multiple. Normalization is normally used to express in the standard form, just like in a normal distribution. Alright? Now, how does this transformation affect the product moment correlation coefficient? That's the main question we are looking at. So before we start, let's take a look at the correlation formula. So this is the correlation formula that you normally use in IEL or at Excel. So we have the numerator part over here and we have the denominator part over here. Here we're only looking at the influence or the changes in the X data only. We're not looking at the Y data at all. Okay, let's move on. Now, before we do any transformation or before we do a full transformation like A plus Bx over C, what we need to do is we need to take a look at each of these first. The first two are very important because the last one, coding, is practically derived from the combination of these two. Okay, so let's see what happens when the data is scaled or translated or coded in this form. So we start off with scaling. So if you look at the numerator of the product moment correlation coefficient, this is how it looks like. Okay, and we are going to see what happens if the X data is scaled by a factor of B. Now, so what you do is, from the original formula, we replace the X as Bx. This is what we have. Notice that B is a constant over here, so we can actually factor it out. Now, once you factor it out, you will notice that the bracket inside is actually the numerator. So by replacing the X by Bx, we have a multiple of the original numerator. So please remember that. Next, we want to scale the denominator because the denominator has got the X quantity over here. So we are only transforming the X quantity. So replacing the X by a factor of Bx, this is what we have. So X replaced by Bx, the B is squared. Similarly, the X is replaced by Bx. Now the next step is, you will notice that this particular bracket, when we open it up, because B is a constant, it will be squared. So let's show you the next step. So if we take it out, B squared, we have a B squared here, we have a B squared here. So once you take it out, you square it, you have a factor of B. Again, you can see the denominator is a multiple. It's a multiple of B. So if you replace both the scale numerator and denominator, this is what happens. See, there's a B here, the numerator. There's a B here for the denominator. And because they appear in both numerator and denominator, we can cancel it off because it's just a factor. So we cancel it off, and what we get is the original correlation coefficient, exactly the same as the original, which actually means that scaling doesn't affect the product moment correlation coefficient. Alright, so I've stated here, scaling doesn't affect the product moment correlation coefficient. In other words, it still remains the same. Alright, next we're going to do another transformation called shifting the numerator or translating it. That means we multiply by a quantity of A. Just shift it to the right by A. Alright, so what happened is this. Replace the x by a plus x. Open the bracket. See, for each of the bracket I open it up. Remember, the summation will be distributed. You have to distribute it. Okay. Same thing we do for the numerator. But in this case, you'll notice that the summation goes in for a and x first, then only multiply by summation of y. So this is what we had. Simplify it. Here, the a, we took it out because it's a constant. Here, if you sum a n times, assuming there are n data, we have na. And for this case, we can't do any more simplifying. Summation f, summation x, summation y will still remain the same. Okay, and then the next step, we break up the last two terms into two fractions, like this. And you will notice that these two terms cancels off. Why? Because the n cancel off, so a summation y is same as a summation y, you minus it off. And what we are left is just these two terms. And this looks exactly like the original numerator. So we can say that the shifting does not affect the numerator. Now let's take a look at what happened to the denominator. So if we shift the denominator by x plus a, we put it in, we place the x as x plus a, open the bracket. Now here, when you're opening the bracket, you have to be very, very careful. And we break it up. Remember, a is a constant, we can put it outside. Here, summation a squared is here. This one, we bring in the summation first before we do anything. And then the next step, we simplify. Summation x times summation and give summation x squared. And the rest, summation a times summation a will give summation a squared. And then we have the middle term, summation a, summation x, two of them. Next step. So after simplifying further, we break up the last part of the expression into three fractions. And you will notice that these two terms are the same, so it cancels off. And these two terms are the same, so it cancels off. So what is left is the original denominator. If you look at this carefully, they are exactly the same. So shifting the denominator does not affect the denominator as well. Shifting the denominator by a plus x does not affect the denominator as well. So in other words, the correlation coefficient is still the same. Okay, let's move on to the last transformation, which we call it coding, because it covers both scaling and shifting or translation. Now, if you look carefully at the coding, we can actually rewrite it in this form as two fractions. And notice a over c is basically a constant. B over c also is another constant. Alright, so it's actually equivalent to as if a over c is replaced by a. Alright, b over c is replaced by b, just another constant. And over here, if you look carefully, b is a scale quantity. A is a translation quantity. So we know that translation and scaling doesn't affect the product moment correlation. So it means if both were to happen at the same time, the same result will happen. So that means we know that the product moment correlation coefficient does not change with coding. So transforming the data does not influence the product moment correlation coefficient. It remains the same. So this is something that's normally not covered in lessons in school, because the main idea is they just want to test your ability to logically figure out. So I'm using a mathematical approach to show you, but I think there are better approaches which I will be showing later on. So just for your information, you know that the whole PowerPoint conclusion be that the product moment correlation does not change with the data that's transformed by scaling, by translating, or by both of them. Thank you for watching. Please make a comment downstairs. Make a comment below, and let me know whether you like this video. Thank you very much. See you. Bye.